going to do an example of simplifying a exponent modulo another number, and it's going to look really complicated at first, but if you do it right, it will take less arithmetic. So let's take the example of 13 to the 32nd power mod 101. So what you don't want to do is don't go ahead and compute 13 to the 32 and then reduce. The technique that works best here is to use repeated squaring because we have a power of 2 in the exponent. And we can actually apply repeated squaring even when we don't have a power of 2 in the exponent, but for the first example, I put a power of 2 there. Let's just take 13 squared mod 101 to begin. So 13 squared is 169. 169 is congruent to 68 mod 101. And then we're going to look at 13 to the 4th. So 13 to the 4th power, we're not going to compute that out, but instead we're going to notice that 13 to the 4th is the same as 13 squared squared. And we know what 13 squared is, mod 101. We know that that is 68. So that's the same as 68 squared mod 101. And still not like a super tiny number, but obviously way better than exponentiating 13. So 68 squared is 4,624. And then if we mod that by 101, we would end up with 79. Let's look at 13 to the 8th. Same sort of thing. 13 to the 8th, well, that's just 13 to the 4th squared. And we know what 13 to the 4th is. We know, that it's congruent to 79 mod 101. So 79 squared. And then 79 squared is 6,241. And then if we do mod 101, we end up with 80. So then the next step, 13 to the 16th power, and that is congruent to 13 to the 8th squared, which, as we said, was congruent to 80 mod 101. So 80 squared. 8 times 8 is 64, and so we have 6,400. And then mod 101, we end up with 37. And then last, we do 13 to the 32, which is the final goal, what we're looking for. That's 13 to the 16 squared, which is the same as 37 squared, mod 101. It's not the same otherwise. And 37 squared is equal to 1369, which, now if we do mod 101, we end up with 56. So if we go back up to the beginning, the original thing we were looking for, 13 to the 32 mod 101, well, the answer to that is 56. So although, this did take some computation, what you can see is that this is much, much simpler than trying to find 13 to the 32, or even just like repeatedly multiplying by 13. We just take advantage of the powers of 2 here and keep squaring it. Let's take this example just one little step further. So say I had 13 to the 34 mod 101 instead. It's no longer a power of 2. So what we'll do in a situation like this is you would still write out your powers of 2. So we know that 13 squared is 68, 13 to the fourth is 79, and so on. So we would still do that same list of computations. But then we would use the fact that 13 to the 34th is the same as 13 squared times 13 to the 32nd. So I'm breaking this exponent up into two separate exponential expressions, both with a power of 2. And I do that because I know the powers of 2 from my computation, and I know that 13 squared is congruent to 68. And I also know that 13 to the 32 is congruent to 56. So even though I don't have a power of 2 as my exponent, I can still calculate, relatively quickly. Once I have a list of the powers of 2, I can calculate what this is going to be, mod 101. 68 times 56 is 3808. So then if I do that mod 101, we're left with 71. We were able to find this solution relatively quickly, and the answer right here is 71. So repeated squaring, the whole point of this is that it's extremely powerful, and don't torture yourself by doing too much multiplication or by doing crazy exponents.
And that's all I'm learning. Hope that we can make a turn and start reversing all our minds and put the work in. We got some work, man.